You are welcome. So in this video I'm going to talk on how to find the domain of a function, that is the possible value that will make a function to be what? To be defined. That will make a function to be what? To be defined. That is the possible value of x that will make this function to be defined. The possible value of x that will make this function to be defined is called what? It's called the domain. That is the number, the real number that you substitute here that will make the number to be defined is called what? It's called the domain. So these two questions, I'm going to start them together because they are similar. So here we have what? We have the linear function, that is, we have the x here is raised to the power of 1, which is linear function. So here we have the polynomial functions. It may be quadratic and other function. So here the type of this function, their domain, the type of these two functions here, the type of two functions here, that is linear function and polynomial function, the domain is always what? Is always positive infinity and negative infinity, sorry, negative infinity to what? To positive infinity. You use open bracket. That is the domain here. The domain for this function is positive infinity to negative infinity. That means your domain is what? Your domain is, that is, x is element of all real numbers. X is element of what? Of all real number. That is, if you put any number here, it will make this function to be what? To be defined. That is, you cannot find, you cannot, if you put 0 here, this number will what? That is 4. So you put 0 here, you simplify it, you will definitely get number. You definitely get a number. That is, the domain is all what? X. That is, f of x will be what? Will be defined for all real numbers. So whenever you're having a radical for a rational function, you have a rational function here. We have a rational function here. So here you understand that whenever you're having linear function which is not, well, we are having linear or quadratic function or polynomial function which is not a rational function, that is, it's not having numerator and denominator, your domain is always what? Real numbers, all real numbers, that is negative infinity to positive infinities. So here we find out that if our x here is 5, that means what? That means you are having what? All you means 2 minus 5, which is minus 3 over 0, which make this which make the function to be undefined. So that is what we don't want to have here too. So you just definitely say that let x, this here, x must be what? That is x minus 5 must not be equals to what? Must not be equals to 0. So x minus 5 must not be equals to 0, which implies x is not equals to what? Is not equals to 5. That means if your x is not equals to 5, that means we have what? You have what? The function we divide. If x is 6 here, you have 5 minus 6 minus 5. If x is 7, if x is less than 6 too, you have it like that. So your function, your domain will what? You can use number line to represent this. So your domain, in short, you just want x is what? Is element of all real number, but with the exception of what? With the exception of 5, which is the same thing. Just use your real number. We have positive infinity, we have a negative infinity, we have what? 5. So negative infinity to 5, that is 5 is not included. This open bracket means 5 is not included. Union 5 to positive infinity, So I have my, so this is the domain for this function here. So we have the third case here, when you are having a radical function, that is a root function or square cube root function and others. So here I'm having root of what? Root of x minus 3. So in this place I don't want to have negative. The function will be undefined if I'm having my negative 1. So it will be what? It will be undefined if you are having negative 1. So definitely this will be what? X minus 3 is greater than or equals to 0, which implies x is greater than or equals to 3. So if my x is greater or equals to 3, this function will be what? Will be defined. So you bring your number line to represent the domain. So here we have what? That is, we are moving from 3 to this side. So you put something less than 3, it will make this function to be undefined. Let's put something less than 3 and see. This is minus 4. Minus 4 minus 3 will be what? Minus 7, which means we are having minus 7, which is a complex number. That is, it makes the function to be what? To be undefined. But if you put a number from 3 upward, it makes the function. If you put 3, that is 3 minus 3, which is 0. Root of 0 is 0. So 0 is what? It 0 make the function to be defined. So we have from 3. So the domain is what? You put your close bracket here, because we are dealing with what? We are dealing with close interval. This greater than is close interval. So greater than greater than or equals to is close interval. So less than or equals to is also close interval. So here we are having greater than or equals to, which is also close interval. So we have 3, that is 3 is included, and all positive number. From 3 to all negative to all positive number, that is from 3 to all number greater than 3, that is from 3 to positive infinity. You use what? You use open bracket here. So that is for that. So I have my last one. I have my second to the last one here to be f of x is equals to x plus 3 all over x square minus 3x plus 2. So here you find out that it's similarly to this function here. It's similarly to this function that I treated similarly, but the denominator here, is what? Is quadratic function. So just simply what? Introduce the same method, that is x squared minus 3x plus 2 must not be equals to what? Must not be equals to 0, because if it is equal to 0 here, we have what? We have a number over 0, which means what? The function is what? Is undefined. So we don't want to have anything over 0, because anything over 0 is what? Infinity. So we don't want to have that. So that means all these places must not be equals to 0. So you now factorize this by factorization method. If you factorize this, you have what? You have x minus 1. Sorry, you have x minus 1 into bracket of for x minus 2. So use the factorization method to simplify it. You have it in this form, which implies, so you find your 2x. X is greater than x is not equals to 1, and x is not equals to 2. That is, you bring this out to find it for you to solve for your x. When after solving for your x, now make your number line. So your 1, let your 1 to be here, and let your 2 to be here. So x is not equals to what? It's not equals to 1, and x is not equals to 2, but x can be in this form. So you have what? Your domain will be negative infinity to 1, but it does not include 1. This means 1 is not included. Union 1 to 2 is not included, but the function say is included. If you put 0 here, it's included. So union 2 to what? To positive infinity, and that is the what? That is the domain. So have a look. That is how to what? To get the domain of some functions here. So let's quickly rush and treat the last one here. When we are having the when we are having a radical function as the denominator. So you know that here we don't want to be equal to, that is two cases here. Firstly, we don't want this function here to be equals to what? To be equals to negative. And secondly, we don't want all this denominator to be equals to 0. That means x minus 3 is x minus 9 is strictly greater than what? Is strictly greater than 0, because we don't want all this function here to be equals to what? To be equals to 0. So once this is greater than 0, that means we have a number here, which 1 divided by the number will give us what? Will give us a number which is what? Divine. So when x minus 9 is equals to 0, which implies x is greater than 9. So just use your number line again. So just use your number, this negative infinity for the number line for x. So place your 9 around here. So place your 9 here. So just from your what, x is greater than 9. So from here, so it's moving what? It's moving towards 9 here. So that means we have what? We have open bracket, because 9 is not included, so you use open bracket. That means 9 to what? To positive infinity. 9 to what? To positive infinity. That is from what? From 10, 12 upward to make this function to what? To be divine. Make the whole function here to be divine. So have a look. That is what? That is my video on this under what? Under under what? Under domain. How to find the domain of a function, that is the possible value of a function, that is the possible value that you input in a function that will make the function to be divine. So we've treated here for linear and quadratic function. You do what? It's all real numbers, that is positive infinity, negative infinity to positive infinity, sorry. So here you have the rational function. Just know that all this will what? All this must not equals to 0. So you simplify for y and use your number line to get the range. So here this will strictly be greater than what? Be greater than or equals to what? Or equals to 0. So here the same thing, the same function here, the same method. Why here you just what? Well, here we just, this function here must be greater than 0, and you solve for it, and you use your number line to get it as I've done earlier. So thank you, and thank you for watching. Have a nice day. Thank you very much.